Action, turn on your camera, Hannah, Tanvi. Okay, try this one. Okay. Put in the chat box once you have your answer. That's not even close, Vivan. Remember what we learned? When addition happened, what was the rule for addition?
Oh, no, because you're not
Mm.
specify what to do, so I just blindly did.
Oh, no. Put your answer in the chat box, everyone. Remember the rules. Still waiting for others to give their answer in the chat box. Kirdana, remember the rules. When you add, what happened? Okay. What did we say? When we add, we said that when we add, we look at the lowest decimal place, right? When we add, we look at the lowest decimal place. This one has what? 0 decimal place. This one has? What is decimal place? Numbers after decimal point. There is no decimal place, 0. This one has 1 decimal place. So the lowest should be no decimal place, right? That's what we think. But there is a problem too. The problem is that the one with the 0 decimal place, the last number is not significant. Remember the significant rules? The zeros at the back are not significant if there is no decimal point. So this one is not significant, okay? So when you add them, 250 plus 3.5, these, the ones, right? Okay, well, you cannot have this for sure, but this one also need to be not significant. Okay, so when you add, you would have what? Let me just write down the answer first. You would have 0.5352. So this one you cannot have. The 0.5 you cannot have. But the 3 also need to be not significant. Because why? Because this is not significant, but this is significant. So not significant plus with significant should be not significant. So this one should be 0 without decimal. So the answer should be 250. Okay? So you have to pay a little bit more attention, not just on the decimal place, but also whether the last digit with the one with no decimal place is significant or not. Okay? And then you have to do this type of addition or subtraction. Okay, try this one. Good job, Hannah. Okay. So for this one, what do we do? Both of them have no decimal place, right? No decimal. Addition means we look at the decimal place, no decimal place, because your answer should have no decimal place. Look at this action. You want to do it like this. Okay, action, help me here. What do we do now?
Um, so since the zeros are behind, they are not significant.
Okay, so is this significant?
No,
Good. Not significant. And I'm going to write n as not significant. What about this?
no,
Okay, what about the 1?
yes,
Okay. What about the 2? The 3?
yes,
What about the 2?
yes.
Okay, so when you add, you have 123. But is this your final answer?
No, you have to put 123.0.
No, no. Okay, so you got until what's important. Okay, now what do you do? Look at this, okay? When you have a not significant added to a significant, your answer cannot be significant. Not significant added to a significant, you have to turn down this into a non-significant number, which is action, which is
So if you don't add if you cannot add the 0 and the 3, would it still remain a 0?
yes. Well, you will have to turn it into non-significant number. We know that all non-zeros are significant. So zeros are not significant. So you have to turn it into 0. Okay. But let's say, okay, so this is going to be 0. This is also non-significant and significant. This is also going to be 0. But is this going to stay 1? Yes, because the number after is 2. So it's going to stay as a 1. Okay. So try this one. Good job, Diksha. I am so proud of all of you. I mean, like, these are not easy to learn, for sure. You guys learn it in 3 days. So this one, no decimal place, so this is gone, right? There is non-significant number, so this is gonna be 0. This is also there is non-significant number, that would be 0. Now what about the 2? The 2 will be 3. Okay, good job. So the answer is 2300. Make sense? Yeah? Okay. Diksha, you have done chemistry, right?
Yeah.
You tell me, what was your experience in your chemistry class?
With significant figures or in general?
In general, do you find your chemistry class as easy as we have made it in these 3 days? Do you feel like, at least in this class in honors chem, do you feel like it's easy in these 3 days?
Like, do you mean that, like,
The sig figs and everything that we learned today?
yeah, I feel like it was made simple. Right.
What about in your class? What was your experience in your school class?
I mean, in our class, we did sig figs in like the beginning of the year, and like we kind of had to rush through it. So we were kind of just expected to like know it and remember it.
That's actually like a very common experience for most students.
Yeah, and if we didn't like on tests and stuff, if we didn't round to the correct sig fig, we'd always get like points off and stuff. Yeah.
I'm just so glad you joined. You joined the classes. That's really good. Okay. Okay. So, now scientific notation. Scientific notation, right? You probably already learned this in your math class. Let's say you have this. How do you make it scientific notation? In scientific notation, there are 2 numbers. Okay, the first number, this number, should be more than 1, less than 10. This one can be equal or more than 1, but less than 10. Okay, and this one is going to be 10 to the power of something. Okay, so at this, you see no decimal point, but you can kind of like understand, oh, they're probably gonna be a decimal point here, right? So you're gonna make this number into more than 1, less than 10. So you bring the decimal point, 1, 2, 3, 4, 5. You bring it there. Okay, so you have 4.6. And how many of that you have to go through? 1, 2, 3, 4, 5. So 10 to the power of 5. Okay. And if you have something like 0.00000032, you do the same. You want to make a number which is more than 1, less than 10. That means your decimal point should be here. And what do? You bring this 1, 2, 3, 4, 5, 6, 7. So you have 3.2 times 10 to the power of -7. Any question? The way, I know some of you might get confused between when is it going to be positive, when is it going to be negative. You can remember it like if you're trying to make a bigger number to a smaller number, right? That is what 460,000. That's a bigger number, right? So you want to condense all the zeros at the later part. That means you need to have a positive exponent. But this one is such a small number. This is smaller than 3.2. That's why you have a negative exponent. That's how you can think about it too. If you get confused between the positive and negative. Okay. Also make sure one thing though. Okay, let's try this one. Okay. Convert into scientific notation. Just make sure one thing. Whatever an amount of significant figure you have in the question, your answer should have the same number of significant figure. Okay, before that, how many sig figs are there in this one? This is a number, one number. Okay, this is not two number. Okay, even though you see this as like multiplication, it's actually a number, one number. And when you look for a significant figure, you don't care about the multipliers, the 10 to the power of whatever. This is the only part that you care about. This is where you look at your significant figures. So you just see a 2. Okay, same, yes. Same goes here. You only see a 2. Okay. Now, okay, do this one. Oh, wait. Yeah. Convert into scientific notation and make sure to maintain that number of significant. Even the significant number is not maintained. Think about the question has how many sig figs and your answer has how many sig figs. Hannah, yours too. The sig figs are not maintained. Okay, good job, Kirtana. Good job, Diksha. This one has the zeros in the front are not significant. This is significant. The zeros at the back are significant if there is a decimal point. So you have 3 significant figures. So your answer, yes, you would think all of you know to do 1, 2, 3, 4. So 3 times 10 negative 4. However, what? This one has 3 significant figure and this one has 1. So you have to make sure you make it 3 significant. Okay? Okay. Okay, do this. Wait, give me a second. I want to see what else do we. Oh, just like. Remember that one? Your first number should be more than 1 but less than 10. It has to be less than 10. If your first number is not less than 10, there's something wrong. Okay, good job, Diksha. Okay, good job, Hannah. Okay, good job, Vivan. That's okay, Akshin. Do you know how to convert into scientific notation, Akshin? Do you want me to explain? Yeah? Okay. So so for example, when you want to convert this one, A, right? This is a normal number. You want to convert it into scientific notation. So the first you have to make sure the number that you want to make in the first number, because there are two numbers, okay, that get multiplied together. The first number should be less than 10, more than 1. That means where do you put your decimal so you can get less than 10 but more than 1? You want to put it between 6 and 0, because that's going to give you 6.072. And then, so you write your number 6.072. Now you bring this decimal 1, 2, 3, 4, 5, 6, right? Because you are making a smaller number to a bigger number, now it will become what? 10. It's always going to be 10. But because you are making, this is a smaller number, you're trying to make it a bigger number, it's going to be now -6. Why 6? Because you are moving 6 place to get the point to be between 6 and 0. Okay? And you have to maintain the sig figs. This one has 4 sig figs. This one also has 4 sig fig. When calculating the sig fig, you don't care about the multiplier. So, for example, this one, you don't see any decimal. That means you want to assume it's at the end. Okay? So where do we put the decimal between?
You want to put it between 8 and 3.
Okay, so 1, 2, 3, 4, 5, 6, 7. And our first number would be
8.34
4 times 10 to the power up. Now we are trying to make a bigger number become smaller. So it would be positive exponent. So 1, 2, 3, 4, 5, 6, 7. 10 to the power of 7. Make sense? Kirtana, do you want to help me with C?
Yeah.
Okay, what do we do?
So first the number, well, you have to like go back 3 times to 1.050.
Okay, 1, 2, 3. The decimal should be between 1 and 0. So you have 1.050. So it's how many times? 3 times.
And that's
So
back. So it'd be 10 negative 3.
good. Okay, good job. Anyone have any question? No? Okay. Now it's the opposite way. You get a you get a scientific notation and you need to make it a normal number. Go ahead, try it. Is there any of you taking regular chem or all of you are taking honors chem? All are taking honors chem? Yeah? You can also put a bar. Okay, so for E, right? 4.500. You want to make it 6. 1, 2, 3, 4, 5, 6. So that would be 1, 2, 3. So it's 4, 5, 0, 0, 0, 0, 0, right? But how many sig figs you have? 4. How do you make this number become 4 sig figs? Whenever you have this kind of problem, go back to the scientific notation. But what if they ask you to go from scientific to normal number? How do you make this sig fig? Some of the zeros significant but not the other. How do you do that? You are going to put a bar on the top of the zero that you want to make significant. Okay, you want to put a bar on top of the zero that you want to make significant. So now you have 4 significant figures. Some of you might not see this type of question at all, but that's okay. You should know though. Okay. Now, how do you do a multiplication? Okay. When you have the same 10, okay. When you have the same base, for example, this A, how do you do it without calculator? This and this, you're going to multiply together. Okay. So you're going to get what? 6.4. 2 significant figure both of them. So it will be 6.4. What about this? Because they are being multiplied, when you have the same base, 10 is the base, 10 to the power 4 times 10 to the power of 3. When you have the same base, what happened? The 4 and the 3 will get added when you multiply them. Okay? If it's division, it will get what? Subtract. Do you see it? Okay, when you have the same base, when you add numbers, when you multiply the numbers, the exponent's gonna get added. When you divide, it will get subtracted. Okay? So try to do these questions. I mean, like, you can use some of the calculator, but try to do, 10 negative 3 and 10 negative 10, 5. I'm gonna add them. I'm gonna get 10 to the power of 2. 8.4 times 4.0, that's gonna give you what? You can do it with your calculator for this. I'm gonna get I'm gonna get around 34. But this is not the correct scientific notation, so you want to make it correct scientific notation, which gonna be, the point should be between 3 and 4. So if I'm gonna make it that way, 3.4 times 10 to the power of 1 times 10 to the power of 2. So I'm gonna get 3.4 times 10 to the power of 3. Look at this, what did I just do? Let me explain again. First, 8.4 times 4, I got around 34. Okay? This and this I multiply together. That means I'm just gonna add the power together. I got 10 to the power of 2. However, this is not the correct scientific notation because what do we know? This should be less than 10. So the 34 I convert into scientific notation, which is 3.4 times 10 to the power of 1. And then I simplify, and this one still whatever it was. Now, these two, I can add them together, 1 and 2. And this is my correct scientific notation. I know you can just like put everything into your calculator. You might not, maybe in your first test, your teacher might not allow calculator for this reason. Okay, and when you do math, when you do more chemistry, there would be a time where it's faster for you to do without calculator. So you want to learn that logic behind. Okay, and of course you can always use calculator anyway. But yeah, try C. Try to show this type of, oh, first I multiply this, I got this, and then I'm going to convert this into scientific notation, and then the 10 to the power of things I'm going to add or subtract or whatever. Do it, action. Look at the sig fix though when you multiply, okay? This one has 4, this one has 3. V1, do you want to do it with me?
Sure.
What do we do first?
Well, first what I did is uh,
The
first
numbers? Mm-hmm.
first I multiplied 6.022 and
With?
yeah, 2.00.
Okay, good. First you multiply this 2, what you got?
I got 12.044.
But with the correct sig fig?
1.2044.
No, correct significant figure. This one has how many sig fig? This one has how many? Yeah, this one has? You got this. You have been getting everything else. You got this. How many sig figs are here? 6.022. The non-zeros are significant, right? What about the 0 in the middle?
Has 4 significance.
Okay. This one has 4 sig fig. What about the 2.00?
Has 3 sig.
Okay. So your answer should have how many significant figure, and you have to round it up to that.
Should you should look at the lowest significant figure, just 3.
Correct.
Just
Okay. So your answer should be, when you multiply these two numbers, your answer should be,
you have 3 significant figures.
which would be, it was 12.044. So it would be
It would be 12.0, right?
Yes. Okay, so we figure out this number. Now, for this one, what do we do? 10 23rd, 10 negative 3 multiplied together, what happened?
We do 23 minus 3.
Yes. Well, basically you add them, right? But because there is minus there, yeah.
Yeah.
So times 10 to the power of 23 plus negative 3. So that's just going to be minus, and you're going to get 20.
20.
Yes?
Yeah.
Right? Okay. Good. Now, what's the problem though?
We have to put scientific notation, and 12.0 can't be acceptable, so we have to
Good.
change the exponent to 21. Therefore, the correct answer.
21 or 1.2? You're nervous?
Yeah, the final answer.
Oh, exponent. Exponent.
Yeah,
Yeah.
exponent.
Yeah. Well, we're going to do step by step so everyone understand. So this is not a correct first number. It should be less than 10. So we're going to move the decimal here. So you're going to get 1.2 times 10 to the power of 1 times 10 to the power of 21. Sorry, times 10 to the power of 20. Now these two can be added together. You're going to get, oh, wait. There should be 0 there. 1.20 times 10 to the power of 21. You guys say it? That's how you should be doing. I mean, like, it seems like, why can't I just use my calculator? Because it seems very, very lengthy right now. But once you actually master this is going to save you a lot more time compared to putting things in your calculator. Especially when the questions like, see, 9 times 3, 27. Okay, 27, 8 plus 3, 11. So 27, I have to move up there. So instead of 11, it would be 12. That's it. Done. Compared to you put 9.0 times 10 to the power of 8. Okay, so you just have to master this. Okay, now the addition and subtraction is a bit harder though. The addition and subtraction is the one that's a bit harder for scientific notation. Now, when you have addition or subtraction, you have to look at the exponent. You have to make sure, look at this please. You have to make sure the exponents are the same. First, you have to make sure that the exponents are the same. Now, what do you do to make the exponent the same? This one, you have to, the smaller one, you have to make it the bigger one. So the bigger exponent is 10 to the power of 3. So this, you have to make it 10 to the power of 3. How do you do it? Okay, so we're going to change this into 10 to the power of 3. Which gonna be? Who can help me here? How do I get this 10 to the power of 3? What will happen to my first number?
It will decrease.
Good, good. It will be what?
It will be 0.21.
Very good. Okay, good job. Oops. 10 to the power of 3. Now that you have the same exponent, also, your teacher might want to see work. Okay, you cannot just use calculator, no work, no points. So that's why you have to learn it the right way. Now, once you have the same exponent, okay, you can do a normal addition like 3.40 plus 0.21, and then you can of course do 10 to the power of 3, 10 to the power of 3. This is going to stay the same, 10 to the power of 3. And this one you can add 16.3. Okay, that's it. What do? Make the small exponent be similar to the larger one, and then you just add them this way. Okay? Smaller become larger. So which one is smaller, -5 or 10 -4? Sorry, which one is larger? Vignesh? You there? Okay, Diksha, which one is larger, 10 negative 4 or 10 negative 5?
10 negative 4.
Okay, that means you have to make this to become 10 negative 4. Go ahead, do it. Make sure to show your work, okay? To show each step, to show this work. This is the most important one though, this part. Even if you don't show this is still fine. But when you change it to this, that's the most important part. I can see so much potential in each of you. Just hope you guys do well in your school year. Good job, Hannah. Is this your first time taking chemistry? Yeah. Honors chem?
I think
Is
so.
it honors?
I think so.
Okay. It's good. Any of you planning to take AP Chem next year? I didn't know you, Diksha. Anyone else? No? Okay, so let's do this together. So we want to make this a bigger number, right? This one will be what instead? This will be 0.32 times 10 negative 4. When you add or subtract, you don't just what? You don't care about the 10 negative 4. It's going to stay the same, okay? So now you are just subtracting these two numbers together. 6.5 minus that number, it would be 6.18. No? That's it. Okay? So those are different rules. Just make sure you review everything, okay? So that's it for our boot camp. I hope to see all of you because I don't want you to lose this momentum. And summer is very important. I mean, like, if you want to get ahead, I have seen so many students cry because of chemistry. So many students cried because of chemistry. So I don't want that to be one of you. If you start early, you're gonna have so much more advantage compared to other students. Okay, so yeah, if you want to, because every year we always like, oh no, next year I'm gonna do well in my. Every year, once you see your last semester grade or GPA, you always feel like, oh no, next year I'm gonna do it right. This is the chance of you doing it right. Okay, start early and yeah. Okay, then that's it for today. Any question? No? Okay. Bye-bye.
Bye, thank you.
Thank
Okay.
you.
Bye, thank you.
Okay.